So anyway, okay, so now we're recording so this is what, and actually you will also be able to access this recording. It's what I'm going to do is I'll put a link. It'll be a YouTube link that I'll put with this section and the homework that's due. The homework that you're going to be doing tonight is in the student journal, so make sure that you have that accessible for the weekend when you go home. It's just going to be 2 pages related to the material we're going to do today. Today's material is actually going to be very, very closely related to, not only is it an algebra topic, but it's also a topic that's going to be used in Mr. Dreyfus's class. We call this solving literal equations. Basically, the idea is that we're going to be looking at equations that are that have more than one variable, and we're going to try to get one variable all by itself. And so sometimes the first couple times you do it, it feels a little strange, but after a while you'll get used to it. If everyone could turn their computers off right now, that would be great. And so what we're going to be doing is we're going to be walking through this sheet, and as you get a hang for what's going on, feel free to move ahead. All right, as I normally encourage you to do. And so let's go ahead and start. It says okay. Let's go ahead and just start with the first problem. All right. And it says solve the literal equation for y. The reason they call it literal is because it has, mostly I just say is because it has more than one letter, associated with it. So in this case, it's got the x and the y. So solving for y means getting that y all by itself. What would be possibly the first step you guys would take to do this? You would think maybe that's if you divided every term by 3, which are 3. There's 3 terms here, right? That could work, but in this particular case, it's not going to be it's likely not going to be the easiest solution. So if we divide by 3, the only problem is this: is that whenever we divide or multiply, we have to multiply every term. How many terms do I have in this equation, Olivia? I have 3. So I have 1, 2, and 3, and I'd have to divide each one by 3. Dividing this one by 3 is nice, but the 4 is kind of a bit of a mess. So the answer is yes, I could, but it may not be the best way to go. Can someone think of can anyone think of a different starting point? Yes. Subtract 4x, and I agree that would work. That would be a good first start. I subtract 4x from both sides. All right. Remember, it doesn't matter what order things are in here. I'm going to have 3y equals. I'll write the minus 4x first, plus the 9. Okay. Now I need y by itself. And Nick, I think I like your idea. What would you do now? Divide by 3. And remember, in this case, we divide everything by 3. Now, I know in the past, your teachers have said, divide both sides by 3. That means the same thing as dividing each and every term by 3. Someone might ask, could I have divided the whole left side by 3? You could have done it that way too. It's better though, I think it simplifies easier if you divide absolutely every term by 3. Now let's simplify. Final answer, y equals, you guys are writing this down, right, with me? Y equals, watch how I write this, negative 4/3 x plus 3. Notice how I don't have to keep the x on the top. I could have written that as negative 4x in the numerator over 3, or I just write negative 4/3 x. All right, that means the exact same thing. So that's our first practice. Any questions?
So that's all we're doing, just getting y?
Correct. So all this is going to be is, this whole section is on dealing with equations that have more than one variable and then getting it so that there's only one variable on one side. Now, Why is this important for Mr. Dreyfus's class? In Mr. Dreyfus's class, you're going to be seeing a lot of formulas. And sometimes you're going to be solving, the question is going to ask you to find the velocity. Sometimes it's going to ask you to find the time. Sometimes it's going to ask you to find the distance. And so what we do typically in science is we solve the equation. Nick, stay awake, you can do it. So we solve the equation for that one variable. I know it's maybe pretty dry. How do you think these people are doing on listening to this tape tomorrow? You're pretty tired today? All that fasting last night? Yesterday? Okay.
I'm so hungry.
Okay, so let's go ahead and let's try this next one. Has anyone done this one yet? So what is this one? It says solve the literal equation for x. So we see the little x over there by itself. And usually the first step, if you can, is probably going to be doing some subtractions like Ines just suggested. What do you think, Johnny?
Subtract the x.
Okay, I can't subtract the x, but I've got an x in two places. This is pretty crazy. How can I get... How can I make just one... How can I make those two x's into just one x?
You can add the x or subtract 5 x.
Okay, could you subtract them? The problem is they're not like terms. Because of that z, you see that z right here? That means that these two terms are not like terms, so we can't add or subtract them. What do you think?
I was just going to say, like, move the x to 3x and 4x.
Okay. How about, does anyone remember how to factor out a number? Okay, let me show you something real quick. So say you have a number like x times 3 plus 5z. How do I distribute that? Just multiply the x by every number? Yeah, Jojo? So what do I get? X times 3? 3x. X times 5z? 5xz. Ooh. So what we can do sometimes is we can distribute, and sometimes when we need to, we can undistribute. In other words, if you see this x here, what I can do is I can factor out that x. And so has anyone ever seen that before? Factoring out the x?
No.
Never seen that before. Okay, well anyway, do you see how we distribute? So what we're going to do is we're going to undistribute. We're going to take that x and we're going to, they call it factoring out. Let's go ahead and let's see if we can do this. I'm erasing it all, and we'll start from the start. We'll start at the beginning. So now I'm going to go. I'm going to say, okay, 3x plus 5xz could also be written as x times what? 3 plus 5z. Okay, so that was a pretty tricky step, right? But can you see how we can do that now? And now that I've got, now the x is almost alone, but it has this big mess right next to it. It has this 3 plus 5z next to it, and I can divide both sides by that big 3 plus 5z. You don't really need the parentheses if you don't want to, but notice. Okay, so this is pretty advanced math for some of you guys, right? What's my final answer? Let me put the x on the left-hand side. X will equal y divided by what? 3 plus 5z. Okay, we could use another one of those, I think, right? Let me see. I'm not sure, but I think we may have one on. Can we try another factoring out just to see if you can do it on your own? Okay. I'm going to go and I'll take this little spot here and I'm going to say 5y minus 3yx. So what can I factor out of these two terms?
Y.
Yes,
The Y.
the y. So I'll put the y in the front, Damien, and what would go inside the parentheses? 5, 5 minus 3x. No, the y's out though, right? And you can always test this by distributing. If you distribute, you get back to what you started. Okay?
What page is that on?
This is still the first page. I'm just like throwing these in as practices, all right? Let me do one more. Factoring. They call this factoring. You could also just call it undistributing, all right? Which sounds kind of silly. But anyway, let me do one more. You guys do this one on your own, right? 7z plus 4zx. Raise your hand when you think you've got that factor, just so we can see it. Excellent. Yes. Who else? Good. Put the z. Oh yeah, we don't. This, I'm just using this. I'm trying to simplify it. So this is just one side of the equation. So what are we going to take out is what do they both share? The z. So let's unmultiply that z. All right. Z parentheses, and so what's the first number going to be? 7, and then the next one is going to be 4x. Excellent. Okay, so you got your first step in. This is our first step in factoring. It's just undistributing. It's not unfamiliar to us because we know the process that creates that number. We just undo that process. So let me go ahead and now can we move on to the next page? What we're going to be doing is just. We're just gonna like walk through this page, this stuff on your own, and every once in a while we'll stop and I'll have you guys do it on your own. I'll check your work, see how you're doing. At the end, if you guys are good at solving literal equations by the end, you're successful and you have, we can move right on to the homework if you want. Okay, so is everyone all right now?
Wait, is there like any other part to that or no?
Was that? All I was doing there was just practice factoring. So I'll just write that as practice.
So we just have to finish this.
We're going to be finished. This pretty much what we're going to be doing during the class is finishing this. And no, at some point, pretty soon, I think you guys need a break. What's that? You'll get a break. You'll get a break at some point soon. All right?
You should come with us.
Come you where?
Lulu.
Who?
Comments.
Oh yeah, I've never been there.
Who gave you that name? You should
You mean the snack bar place?
Yes.
I've never walked in there.
I'll buy you a cookie.
Not even stepped in there once.
You gotta have a chocolate chip.
I know. Do they make their own cookies or something?
Yeah.
Oh God.
Have a chocolate chip cookie, put it in the microwave for 17 seconds.
Okay. All right. Well, let's go to this page.
Can you go back real quick?
Yes. Page. Let's go ahead and see if we can get some. Let's see if we can get a few more of these behind us. All right. So okay. So here is. This is actually pretty good. What I'll do is I'll do the first two, and anyone that wants to see if they can't just finish these right now, that would be great. But what I want to do is we'll take a break right after I finish this page. But how many people still want me to work with you? Okay. Okay. So on this one here, we're going to be looking at. When did I do that?
You just did it. You just did it, don't worry. But the video restarted.
The video restarted? Okay.
Stop your jaw. Yeah.
Am I good now?
Yeah.
Okay. How much? I wonder how much mute I had on the previous page.
No, you know,
Oh, I just did it?
that's how I knew it was me.
Thank you, Jojo. How'd you know it was mute?
Blue.
Okay. Well, anyway, thank you so much. Keep going. All right. So anyway, Johnny, we're going to solve for y here. So look at the y in the equation.
Yeah.
And so, what would be a first? What looks like the first step for us on this one? Just like solving regular equations. Notice how we remember how we usually do subtractions and additions first.
Add x.
I would add x to both sides. Excellent. So add x to both sides. Oops, sorry about that. Add x over here. I'm making a mess. Why does my eraser not work here? Okay. All right. So I add x to both sides, and then I get 3y by itself equals x plus 9 or 9 plus x, doesn't matter which. Next step. Divide everything by 3. Right now, I think that some of you may have in the past you'd like divide this by 3 and you divide this whole thing by 3. It's usually easier, I think, to remember to divide each term by 3. It often simplifies easier, and it means the exact same thing. Okay, so y equals x over 3. Can anyone think of a nicer way to write that? A different way to write that?
X3.
1 over 3 x. Awesome. 1 over 3x. Sometimes it's like you look at that and you go, yeah, I think sometimes we can get confused when we see something like an x over 3, but when we can...
Do you accept the x over 3 though?
Yeah, that's fine. Plus what?
3. Plus 3. Right?
Plus 3 at the end. Now I'm done. Okay? All right? I'm going to do this next one, and then the next two I'm hoping you guys can do on your own. So, again, solving for y on this one. Kurt, are you moving ahead?
Yeah.
Who's moved ahead so far? Oh, very good. Ines, yeah. Are you on like page 20 yet?
No, I'm not.
No, not yet. Okay, so let's go to first step on this one is going to be what, Kai?
Like add to y.
Okay, careful. We're going to be solving for y, right?
Oh yeah, then subtract 2x.
Subtract the 2x. Good. And so now we get minus 2y equals. I put the x first. Do you guys ever remember slope by intercept form?
Oh.
Does that sound like a nightmare you remember? Okay. Well, anyway, the only reason I'm putting the x first is because later on when we talk about slope intercept form, the x is usually the first term. So that's the only reason. It doesn't really. It means the same thing. So I'm going to put a minus 2x plus the 5. Now I divide everything by
2.
the net minus 2. Again, I can divide the whole left and right side, or I can do the smart thing and divide each and every term by negative 2, and that's what I'm going to do. Negative 2, negative 2, negative 2. Now I've got y all by itself as I wanted. What's just going to be an x plus 5 over 2. Does it matter where the negative sign goes?
No.
All right. So the negative sign can be on the bottom, it can be in the top, or it can be in front. So what do you think is going to look the best?
Negative minus 5 over 2.
Minus 5 over 2, correct. I think that's the nicest
I just
look.
wrote plus the minus the 5.
But you could have wrote plus minus 5 over 2, or you could have actually theoretically wrote plus 5 over negative 2, right? Usually in a book, they would probably, if you're looking for the answer, they'd probably put the minus sign, just as I have it there. So, like right there in the middle. Okay, now your ticket to your ticket out is going to be to solve these two. All right, and if for those people that are, how do I say, those people listening to this recording, this YouTube recording, what I'll do is I'll pause. If I can figure out how to pause it.
To the right of the ring.
All right, and then when you're finished, then take a look. Okay, we're back online here. Take a look at the answers.
Could we look at the Google map?
Yeah, got it right.
Actually, let me.
Oh.
Wait, could I see that again? I didn't see the first one.
You did?
Yeah.
All right, I'll let you see it.
Oh, it's confusing.
How many people got it? You're helping out. You helping me? Oh, Caitlin. You make sure he knows what's going on.
Mr. Shy, I got that one. I got X, Y, that meant 5 minus 4. I don't know how I
Okay, stop for a second. All right. Oh, I know what you did. Okay, so don't leave yet. So what you did was this, because I was thinking the same thing for a second. I'm going, oh, I need to factor out the x, right? So you factor out the x. You go, you'd say y equals x times 5 minus 4. But what is 5 minus 4?
1.
It's just 1. So that's the same as y equals x, isn't it? So you don't have to, so once that becomes 1, then you're kind of done with it. That's the same thing as y equals x, and as I stated up there. Okay? Does that make sense? It's pretty cool how you did that, but it eventually simplifies. How do we do on the, anyone need any help on either of these? Can I just ask one other thing too? One of the reasons, I guess I never really emphasized it before, but one of the reasons you guys are sitting together is because I'm expecting that hopefully one of the two of you in any one of these groups knows what's going on, so that you can help the other person. That's benefiting both of you. Your ability to explain is helping you, and your explaining it to that person helps them. And we will be moving the seats around, but to the best of your abilities, professionally, just do what you can to help each other. You guys have 5 minutes. All right. And for you guys taking a break, hopefully Mr. Haynes is giving you a moment too. But he's not listening to this, so I'm not sure. But see if you can take a little bit of a brain break right now, if you can, and we'll start up in 5 minutes. Okay, so we're started again. Again, those people in the other classroom will have to just survive that. Hopefully they got a break, and if not, if you didn't, maybe you might want to go ahead and play this to Mr. Haynes. But anyway, let's go to this next problem. Okay, so this next problem is actually really different because how many variables do we have here? We have 3, but we're still going to do the same thing for the most part, and that's going to be, in this case, we're going to try to get the x all by itself, and in this case, we also need to do some factoring. So let's go ahead and let's see if we can start with that. So, Loy, what could be? Do you notice how we have the x in 2 places here? All right. So again, when we have the x in 2 places, we're going to think factoring. All right. Even though that's a brand new term for you guys, or as I said, undistribute that x. So Hilton, how can I undistribute that x?
You can do X and then in parentheses 2 plus.
Okay. Everyone see that? Equals m. So he took the x, he put it on the outside, and in the parentheses, he pulled that x out, right, of every number. Now I need to get x by itself. It's not by itself because it's with this thing called a binomial 2 plus x. What can I do now, Ines, with that 2 plus k? I'm sorry.
Divide it.
Divide the whole thing, right? So I divide this by the 2 plus k. If it helps you to keep the parentheses on it, you can, but you don't have to. And so what happens to the 2 plus k? And I'm left with just the x. All right. So let's go to,
I have a question. Can I put this in the fridge?
yeah, I have another question too. Is 5 minutes and 9 minutes the same thing, or are they very, very different?
We're talking Google.
Okay. You guys are behind, unfortunately. All right. So, okay. This one is our hardest one so far. But again, we need to think from the perspective that we want to get the the x by itself. So how many places do we see the x?
2.
Yeah, we see it twice here, right? So we know we're going to need to do that factoring thing. We could do the factoring now, or we can do the factoring after we subtract the 3. So there's 2 things we could do first. Any preferences, Sergi? What would you do first? I that sounds good to me. Subtract the 3 first, so that the only terms on that side are going to be the ones with the x's. So I'll rewrite this as 5x. Am I still recording? Yes. I'm going to rewrite this as 5x minus kx equals y minus 3 or minus 3 plus y. Your choice. Okay. This is what you guys coming in late missed is how, again, do we get that x, those 2 x's, how do we make 1 x out of those 2 x's? Factor it out, right? Caitlin, what will that look like on the left-hand side?
X times 5 minus 10.
Excellent. Equals y minus 3. And now x is almost by itself, but it's kind of standing out there, Johnny, with a big binomial 5 minus k. So how can I get the x by itself?
Divide the 5 minus 1.
The other Johnny. Divide by the 5 minus k. The whole thing, right? If a binomial that's in parentheses like that really is, it's like a brick. It's really stuck together. So don't think of them as being separate. I'm going to divide by the 5 minus k. And I divide this one by 5 minus k. And these 2 will cancel. And I'm left with x equaling y minus 3 over 5 minus k, which looks like a big mess, but hey, that's for someone else to deal with. You got it. You did your job. You solved for x. Done. Okay? Now, moving on. Now we're going to be moving into... okay, go ahead. All right. Go ahead, take a moment and copy it. It's pretty tricky stuff though, huh? But it's really critical. It's really helpful when we do science and having the ability to solve for the variable. Mr. Dreyfus will show you that. So, can I move on?
Yeah.
All right. And now what we're going to do is we're going to actually get into real formulas. So let's look at example 3. So instead of just a whole bunch of x's and y's and things like that, it says this is a formula for the surface area of a rectangular prism. All right. A rectangular prism is anything that has that looks like a box. Basically, that's a rectangular prism, a box. Okay. So it doesn't even matter what it does. What this thing is asking us to do, though, is to solve for L. So let me rewrite the equation down here again. S equals 2LW plus 2LH plus 2WH. Ooh. Just so you know, those are length and width and heights. Okay? So how that formula works is not a concern of yours. The only concern you have is the mathematical part of this, which means trying to somehow miraculously getting an L all by itself on one side of the equation. Has anyone already started this problem? You have? Coverham's done. No. Okay. Any first steps? Suggestions?
Is that an S or a 5?
That's an S. It means surface area. It's short for surface area. So if you had to paint a shoebox, this would be the formula for finding out how many square feet of paint you'd have to buy. All right? So don't worry about what the formula means. What's going to be the first thing I'm going to do?
I'm gonna take a guess and maybe you want to distribute the L.
Do what? Say it again?
Distribute the L.
Undistribute it, you mean? Right.
After it,
We can do that. We can do that. Do you want to factor out the L first? So you'll be factoring out from these two, right?
Yeah.
The other thing we could have done is we could have subtracted the 2WH from both sides so that only the L terms were there. But this is going to be fine. So S, let's watch this. So S, I want to get the L out of those two numbers, right? Just those two.
Put an L on the
And so Shane, I'm going to put an L here and then a parentheses. And what comes next?
2
Yep, plus 2H. And this thing out here is still not moved, all right? So now I've got the L pretty much isolated. I need to get it all by itself. What's my first step when I...
Move it to WH.
Correct. I want to do that first. So now I've got S minus 2WH, or I could have written minus 2WH plus S equals L times 2W plus 2H. You guys notice I do a lot of writing. Really, for the time it takes for you to just write a line like that, don't cheat yourself from the opportunity to make sure you don't make a mistake here. Last step.
Put the 2W plus 2H on the other side. On the bottom of the S minus 2.
In other words, you divide it, right?
Yeah.
So 2W plus 2H on the bottom here over 2W plus 2H over here. That cancels, and I'm down to my answer here, right? L equals S minus, what a big mess, huh? WH
2W.
over 2W plus 2H. So if you know the surface area of your shoebox and you know its width and its height, you can find its length. Crazy formula, but the most important thing is that you just mathematically were able to get there. Why did I not, can anyone suggest to me, tell me why did I subtract the 2H before I divided? Because if I divided by the 2W plus 2H, I would have had to divide every term by that. And it would have just made a big mess. So subtracting, it's just very much like we would normally solve. We would subtract numbers first before we did our division. This is even with the most simple problems that you guys did in the first section. Okay, so let's, all right, let's move on. Any questions? Let me get my eraser here. I can't tell the difference between my erasers. All right. Okay, let me just let me just move on to the next page. On my all right. Okay, so here's some common formulas. Has anyone ever seen this, the one with the C? Let me see. what is this formula here? This one here. It's the formula for converting.
Yeah, it's Celsius to
Right. Celsius to Fahrenheit. All right. So one of the questions might be, it's like, is it possible to change that equation to something to change that equation so it's Fahrenheit equals? This one here, this next formula, it's called simple interest. Does anyone recall what interest is? Not like interesting, but in terms of like a bank or an investment.
Chris?
Okay.
You borrow money and then you have to pay interest.
Right. And an interest is usually a percentage based on how long you have it. So simple interest, for instance, would be like 10% per year. So if you take out a loan for $1,000, what that says is that after a year, the interest that would accrue would be $100, 1/10 of what you just borrowed. And then the next year you would owe $1,200. So the idea is that, if you don't pay off your loan quickly, what happens is that interest builds up and makes it more expensive. What's also nice, though, is that interest is also a reward for investing money. So say you have $1,000 and you want to invest it with a 10% return, then what happens is every year you end up getting that money. So interest can be used against you, like if you're borrowing money, or it can be something that benefits you when you invest money. Typically the higher interest, things that produce higher interest are high risk. And they could also, but high risk investments, may go under. But anyway, we could talk more about that later. But in terms of interest, the word P, the P in interest is typically, this is set up for investment. Principal is the money that you put in it. All right, so say you have $10,000 and you want to invest it. That's called your principal. The R is your rate of is the rate at which you're going to the rate that they give you. So if you do a really very safe investment, maybe it's going to be 3 or 4%. Say you do something really, an investment on something that's brand new, like you want to invest in rockets that go around the moon. With Elon Musk or something, that might be a little bit higher, but it may be higher risk too. And then T, what do you think T stands for? Time, typically in years, okay? So it has it right up here. But principal, again, is the money, if you want to write that in there, it's the money you invested. And the higher the interest, the more money you get back. This is a formula that you're going to see with Mr. With Mr. Dreyfus. He's not going to use the letter D. He's actually going to use the letter, he may be using the letter X, but it's the same formula. Distance traveled equals rate times time. All right? So let's go ahead and do a really, really tricky problem, and we'll do this one together. You guys gonna be okay? I know this is really... I know this is not easy, and it's not really exciting, and Nick is definitely showing it over there. You're going to be good? So Nick, let's go with this one here. So we got C equals 5/9 times F minus 32. I'm not sure how you guys would ever do this on your own, but you did it on your own?
I mean, it's correct.
There's two ways to start it. One way to start it is you could distribute, or the other way to start it would be to multiply both sides by 9/5. And can anyone tell me why I would multiply by 9/5? That happens to be the easiest first step, by the way. What does multiplying both sides by 9? How many terms do I have on the left side? Just one, right? And I only have one on this side. What does multiplying by 9/5 do? What's that? It undoes this mess here, doesn't it? Okay, that happens to be the first best step. Why would I know that? Because I've actually done this problem 100 million zillion times. But that happens to be the first step. You could distribute though. You could have distributed. All right. So now that I've got Kai half asleep over there, and I've got 9/5 C equals F minus 32. Now the question comes, what's the last and easiest step of this whole problem? I'm just going to subtract. I'm going to add 32. Got it. All right. So now I add 32 to both sides. I've got 9/5 C plus 32 equals F. And most of you might want to just go ahead and put that F on the other side. So you go F equals 9/5 Celsius plus 32. You know, one of the an easy conversion from Celsius to Fahrenheit is to just double the Celsius value and add 32. All right. So if it was if it's going to be 10 degrees Celsius, what is it in Fahrenheit? 10 degrees Celsius is approximately 20 plus 32. Yeah. So anyway, just so you know. Okay, you guys with me? Which has the greatest surface temperature? I have no idea why that question's there. No, there's no. There's supposed to be more to that problem, but we're just gonna skip it because I'm gonna let you do that. Okay.
Just guess.
Oh, you can guess. Which one do you think it is?
Mercury.
Mercury always faces the sun, so I'm not sure what they're doing with how they're doing. Oh, save those, because I refill them with spring water. Okay, I have some filtered water upstairs. So Mercury's a little screwed up because the part that faces the sun is really. Everyone knows that Mercury is closest to the sun, right?
Yeah.
So the part that faces the sun is like unbelievably hot. But the part that doesn't face the sun is unbelievably cold because absolutely no sunlight falls on it.
Where's like the midway point? I always wonder
427
that.
degrees
They call those
Celsius.
the terminator points. Yeah. So if you could, there's probably a line right there on Mercury that you can stand, and one half of your body's gonna burn, and the other half's gonna freeze.
That'd be so sick.
Don't go
Yeah,
there.
I
Yeah, but that's literally sick.
I want to
Yeah.
see like a video.
Yeah.
I want to see a video of that.
It's
Someone should like
One half.
Okay.
like someone should just sacrifice it.
Okay, and Mercury, the Venus, on the other hand, is because it's covered in clouds. What happens is all the heat, water vapor is a greenhouse gas, and what it does is when you have clouds that cover your entire planet, it means that a lot of the heat cannot get out. It's like a blanket that covers your whole planet. The temperatures on Venus are about 700 degrees Fahrenheit.
It says 864.
And it's basically like it's like a super hot pizza oven everywhere, lava flowing all over the place, volcanic action.
Venus
Pretty crazy. What's that?
Venus is hotter.
Venus should be hotter. Yeah, that's what I would say. Did you just look it up? Google it.
800 degrees.
Okay, let's go ahead and move. We only have 2 more pages, and then I'm almost. I don't want to do that.
Yeah.
How do I undo that?
The X.
Oh, okay, X. Sorry about that. All right, I'm just going to move forward to the next page, and let's go ahead and do a couple quick questions here, and we're going to be we'll be pretty much done. Whoa, I think this is it. Actually, this is our last page, and then you have 2 you can do, and then we're going to start homework in class. Okay? Yes. Absolutely. Go ahead and turn on the hot water. Okay. So, hey, let's do this problem here. Investors, business people, future people, business people. It goes, you deposited. You ready? So we're going to use a formula. You deposit $5,000 in your account that earns simple interest. After 6 months, your account earns $162.50 in interest. What is the annual interest rate? So what we're looking for is what? What's the last question saying?
What is the annual?
Yeah.
Interest rate, right? So let's look at the formula again. All right. It says interest equals P. This is from the other page. PRT. To do this problem, and how you do your problem in Mr. Dreyfus's class is what you're going to do is you're going to solve the formula for the variable that's being asked for. In this case, what variable should I solve this equation for? R, right? That's your interest rate. So to solve for R, I can, in one fell swoop, I can divide both sides by what two letters? Joe, what two letters could I divide that by?
P and T.
P and T. Yeah, your voice got really feminine for a moment here. All right. So P and T. Therefore, the P's cancel, the T's cancel, and I'm left with? I get the R, right? So I've got R equals I over P times T. Now, theoretically, I've got all these values, and I can plug them in. So R equals... What is I in this case? It's all right. No, that's right. That's fine. It'll click. It'll click. You'll hear it.
It's gonna blow up.
I is 162.5.
Okay, thank you. It is 162.5 over the principal, which is 5,000, times what? Now remember that time is in years. What's 6 months in years?
Half a year.
Half a year. So times 0.5. So this is where you guys, how many people have got their calculator already? Right?
But it's not bad.
Yeah, it's somewhere. I don't know where it is.
I got it.
Mine's deep inside my backpack. I didn't know
I have it, but everything.
All right.
No.
Wait, why is it 5,000.05?
Turkey.
What's that?
0.5.
0.5?
No, I'm saying why is it?
Oh. So
I don't want me to buy it.
so tell me, what is, okay, so what's did anyone calculate the interest rate yet? I think Shane's coming close.
It's it gives me error every time. Error.
Really, 162.5 divided by, what's 1/2 of 5,000? 2,500, right? All right. I'll do this for you guys. Oop. Okay, 162.5 divided by 2,500
0.065.
is 0.065. 0.065. If you move the decimal over two places to the right, is the percent rate. So you could write. There's two ways to write it. You could write it as 0.065, or if you're a banker, you would probably write this as 6.5%. All right. So anyway. I think that's all I have for you guys, except I have this monitoring progress problem on the next page, and that's going to be your ticket to, once you've done these two, I'm going to ask you to go ahead and start your homework. And right now I'm going to probably, for those people listening on the recording end, I'm going to pause. I'm going to let you skip number 11, though. Oop. So only do number 10. And when you're finished with number 10, go ahead and press play again, and you'll be able to see the answers. Okay, the answer to... okay, did you guys get the answer to number 10? Were you guys able to do that on your own? What is it? Yeah, and the key thing is like when we do the test next week, the key thing is that you're going to be able to show me that you can actually convert the formula to the right letters. So again, we have for number 10, you have interest equals principal times rate times time. And you're going to divide, in this case, you're going to be asked for how much money you deposited. So you're looking for the principal, right? So you divide both sides by the rate times the time. Right, and so principal, so now you have the formula principal equals interest, the money you made over rate times time, which in this case is 500. All right, oh, and the tricky part here, if you didn't do it, is that you need to convert that to the percent to decimal, which is, in this case, you move the decimal place over 2 places to the left, and you get 2 places to the left. 0.04 is the interest. So 0.04 times 5 years, and that comes out to, in your calculator, $2,500. All right. So right now, with your extra time, if you looked on, then we'll look at my essay to find out what the assignment was.
It's workbook pages.
It's it's going to be the student. So it's in the student journal with 2 pages.
25 and 26.
So you got 25 and 26. So if you have time right now, go ahead and open that up. Why don't you go ahead and take a quick look at it, and then I'll and see if we can't get some of it done. For you guys on the recorded end of this thing, you guys have a great weekend, and I'll see you on Monday.